So I think we are in the position to take an exercise, and this is exercise 8.1. This is from NCRT book, Trigonometry exercise 8.1. So let's take first question of this exercise. It's given that in a right angled triangle, right angled at B. This is A, this is B, and this is C. It's right angled at B. That means this angle is 90 degrees, and AB, this is given as 24 centimeter, and this BC, it's also given as 7 centimeter. Now first of all, let's find this AC, and I hope you know that this Pythagorean theorem, this PT, this says that hypotenuse, this is our hypotenuse, this AC, this hypotenuse square is equal to base square, this base square, plus perpendicular square, P square. Now we have to find this hypotenuse. Let's keep this as it is. And this base is as 7. So 7 square plus this P. This is 24. 24 square. Now hypotenuse square. This is equal to 7. 7 square is 49, and this 24. This 24 square is, this is 576. See, now 49 plus 576 is 625. That means hypotenuse square is 625. So hypotenuse will be equal to, this square will go as a root over here. So this is square root of 625. That is 25. So hypotenuse is 25 centimeter. So we got this hypotenuse, it is 25 centimeter. Now see, this is the first part of our question, that is we have to evaluate sine A and cos A, and in second part we have to evaluate sine of C, cos of C. Now let's draw a right angle triangle over here. It was A, B and C. This was 90, and this 7 centimeter, this was 24 centimeter, and this we calculated as 25 centimeter. Now first of all, let's evaluate this sine of A. That means we have to get sine of this angle, this. Now as I have discussed, the side opposite to the angle of consideration, this is our angle of consideration, so side opposite to it, this side, this is perpendicular now, and just adjacent to this side, this is our base. So for sine of A, we know sine is equal to perpendicular by hypotenuse. So for A, sine of A, this is our perpendicular, that means it's 7 centimeter by this base, sorry, hypotenuse, this hypotenuse is this one, AC, that means 25 centimeter, that is 7 by 25. This is the value of our sine A. Now similarly we have to find cos of A. Now as you know, cos of A, it is base by hypotenuse, so angle is same, this is our angle, so perpendicular base hypotenuse will remain same. This is our base now, this AB, and this AB is 24 centimeter, and this hypotenuse, this is same, 25 centimeter, so it will be 24 by 25. This is our cos of A. I hope it's clear. Now let's draw this triangle again, A, B and C. This was 7 centimeter, 24 centimeter and 25 centimeter. Now in second part, this sine of C, we have to consider this angle now, this C. So side opposite to this, it is this side. So this is our perpendicular, and just adjacent this side, this is our base. Hypotenuse will remain same. So we have to get sine of C. As you know, sine is perpendicular over hypotenuse. So for this C, perpendicular is this AB, so it's 24. Now hypotenuse will remain same, it is 25. So this is our sine of C. Now let's calculate this cos of C now. Cos of C. See, cos is equal to the base by hypotenuse. So what is our base for this angle? This bases are this BC. So this BC is 7 and hypotenuse will remain same 25. So cos of C equal to 7 over 25 and sine of C is equal to 24 over 25. This is our question number 1. I will try to discuss as many questions as possible. Now let's take this question number 2. And for this question number 2, it is figure is given. So figure is like this. This is P, Q and R. This PQ is given as 12 centimeter and this PR is given as 13 centimeter. This is not given. It's right angled over here. So we have to evaluate tan of P minus cot of R. This we have to evaluate. So first of all, let's evaluate what is the value for this base. See, this is right angled triangle. So in right angled triangle PQR, we can use Pythagorean theorem and it's like this. Hypotenuse square is equal to base square plus perpendicular square. So this is our hypotenuse. This, it is 13. So 13 square is equal to base is this QR. We have to calculate this QR square plus this PQ perpendicular square, it is 12 square. Same. Now 13 square. 13 square is 169. It is equal to QR square plus this 12 square. 12 square is 144. So take this 144 to this side. It is 169 minus 144. That is equal to QR square. And this 169 minus 144 is 25 equal to QR square. Now the square will come as root over here. So QR will be equal to 5 because square root of 25 is 5. So we get this value for QR and QR is 5. So we got this value for QR and it is 5 centimeter. Now let's calculate this first, tan P. So angle of consideration now is this angle P. This is angle P. Now side opposite to this is our perpendicular and just adjacent, this is our base. So this is hypotenuse. Now tan of P, as all of you know, tan is equal to perpendicular over base. So this tan of P, this is perpendicular. Perpendicular is 5 divided by base and base is 12. So this is our tan of P. And let us evaluate this cot of R. Cot of R. See, now our angle of consideration is this R. So side opposite to this one, this is our perpendicular and this will be our base and this is same hypotenuse. Now cot R, as you know, cot is just inverse of this tan. So it is equal to base by perpendicular. Now for this, what is base? It is 5. And what is perpendicular? It is 12. So cot of R, it is equal to 5 by 12. And this tan of P, it's also equal to 5 by 12. Now we have to calculate this tan of P minus cot of r. So this will be equal to tan of p minus cot of r equal to 5 over 12 minus 5 over 12. So this is equal to 0.